With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is two particles x and y with equal charges after being accelerated through the same potential difference enters a region of uniform magnetic field and describes circular paths of radii r1 and r2 respectively. The ratio of the mass of x to that of y is, and the given options are r1 by r2 whole to the power 1 by 2, r2 by r1, r1 by r2 whole square, or r1 by r2. So now we have, see, we are having two particles x and y with equal charges. Okay, the charge of these two particles are same and they are being accelerated through the same potential difference. Okay, and they are being entering in a uniform magnetic field. Okay, so we have to apply the formula for uniform magnetic field one. So we have radius of the circular path given as, for a particle moving in a uniform magnetic field, is given as r equals to mv by qb, right? So here m is the mass of the particle, v is the velocity of the particle, q is the charge of the particle, and b is the magnetic field. Now see, we are given the charges are equal and the magnetic field is equal, but we are not given any information about the velocity. Okay, so let me just modify this formula. So we have, see, kinetic energy of a particle with velocity v is given as half mv square, right? And also we know that the kinetic energy is equals to q into v. Okay, where q is the charge on the particle, okay, and v is the potential difference. So from here, if I find the value for velocity, we will get 2 q v over m whole under the root. Okay, so this is the expression for velocity in terms of voltage difference. So let me replace the value here. To get the general formula for radius, we will get m into, this is under the root 2 q v over m whole divided by q into b. So after solving, we will get, from here this m and m will cut out and we will be left with under the root m. This q and q will cut out and we will be left with under the root q in denominator. So in the numerator part, we will get under the root 2 m v divided by b root q. Okay, so now this is the expression of radius in terms of mass, potential difference, charge, and magnetic field. Okay, so from here we can, it is given in the question that the magnetic field is uniform, the particles are having the same charges, and they are being accelerated through the same potential difference. So now the dependency of the radius on the mass is directly proportional to the under root m. Okay, so now we can write the radius of the particle x, which is equals to, which is given as r1, right? It is given r1. So r1 will be proportional to the mass of particle x, so I can write here mx. And similarly for particle y, we will have r2 will be proportional to mass of y. Okay, so now if I take the ratio, so we will get under the root of mx over under the root of my. This is equals to r1 by r2. Okay, so if I simply take the square both sides, so we will get mx over my equals to r1 by r2 whole square. So this is the required ratio of the masses of the particles x and y. And from the given options we have A, B, C and D. Option C is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.